Hello, my name is Lamang Nugroho. I'm from the Department of Mathematics, Faculty of Mathematics and Natural Science, Universitas 11 Maret Surakarta. I will present my article entitled Signal Analysis of COVID-19 in Indonesia with Continuous Wavelet Transform. Introduction. Signal analysis. In math, scientists used to Fourier analysis to analyze the signal. The main disadvantage of the Fourier transform is that it collects global frequency information, which means it returns the frequency value across the signal. The decomposition of Fourier transform cannot be used for every signal. For example, electrocardiography signal, when the signal has a characteristic short oscillation interval. The wavelet transform make it possible to decompose the signal function into a set of wavelet. Wavelet comes from French, which means small wave. A wavelet is a wave with an oscillation interval based on a local time. Wavelet has two basic properties, namely scale and location. The scale or a dilatation of the determine the stretching and the compression data the wavelet function. The scale relative frequency of the wave. Location depends when the wavelet is located based on the unit of time. The parameter S indicate the scale of a set of wavelet. If the value of the scale is small, map the function sprout with Higgs frequency value. On the other hand, if the scale value is large, map the stretching of wavelet function with low frequency value. The basic idea is to compute how much of wavelet signal in particular scale and location. We use wavelet and wavelet transform. Wavelet transform can extract local spectra and temporal information simultaneously. We have this probably the biggest reason to use the wavelet transform. This may be preferable to using something like a short-term Fourier transform, which requires chopping up a signal into segments and performing a Fourier transform over each segment. There are two types of wavelet transform, is continuous and discrete. Different of each type is given. The difference between these two types is continuous wavelet transform uses every possible wavelet over a range of scale and location. It is an infinite number of scale and location. While the discrete uses a finite set of wavelet, it is defined at particular set of scale and location. Some family from discrete wavelet transform is Hara and Dawidges, and continuous wavelet transform is Morlet and Mexican Head. In this research, we use wavelet power spectrum and Morlet wavelet to analyze the signal. COVID-19 is a disease that has spread through the world, including Indonesia. The spread of COVID-19 case through the direct contact from infected individual transferred from human to human. And from droplet Koch and sneeze. One step to prevent the spreading of COVID-19 is wearing masks and washing your hands. COVID-19 in Indonesia began a pandemic disease when an infected individual was first commented on March. In this research, we used positive confirmed data from June 2020 until 30 June 2021, and this is the signal on the wave of COVID-19 in Indonesia. Material and method: continuous wavelet transform for every scale S and locals in time tau. We use the continuous wavelet transform. The scale of S is the scale of a wavelet transform. Xt is the domain of the data, and tau is locals in time or time translation. So wavelet transform spectrum is the reconstruct or continuous wavelet transform to spectrum. Written as Sx is wavelet power spectrum and Vx is continuous wavelet transform. Wavelet function: the wavelet of the function of modeled wavelet written as where omega 0 is to wavelet period and t is time translation. We can reconstruct it to sine and cosine wave that give a real and imaginary value of wavelet. To get the wavelet value, we should normalize the real and imaginary value. Before we transform the signal with continuous wavelet transform, we need choosing the set of scale to smooth the output of continuous wavelet transform. This is the equation to for the set of signal where S0 is lowest scale of continuous wavelet transform and Sg is the highest of. So G is numerous amount of data used, whereas null is obtained from Fourier wavelength, like this one. C is the frequency of wavelength. Lambda 0 is a Fourier wavelength. From the scaling process, obtain value of G and the set scale of continuous wavelet form. After we get the set of scale, we should we get the coefficient wavelet. The coefficient wavelet that obtained from scaling and time translation. We get this value from coefficient wavelet. The value repeat coefficient value on every translation. So continuous wavelet transform, we multiply the coefficient wavelet to the wave that we want to analyze. This is a wave that we get after continuous wavelet transform. This is wave from scale 1, 2, and 3. Also, we get the wave of this with every scale and time translation. we can reconstruct continuous wavelet transform to wavelet power spectrum, and we get this spectrum when the blue one is lower data fluctuation and the red means highest data fluctuation. So from the period scale 2 to 4, from data 418, we get a wavelet power level 3.09, and from period scale 4 to 8, and data from 477 to 483, we get a wavelet power level 3.6 and 3.57, and a period signal of 16 until 32 in the dataset 318 and 389. We got wavelet power level 1.4 to 2.2. So the conclusion, the wavelet power spectrum model is shown from figure 1, which show an increase in the cases. From the plot, it can be shown that the highest increase in case occur in the period from 21st June 2021 to 30 June 2021. There was an increase in the cases in the 30 January period 2021 to March 25, 2021, but not higher than the period June 2021. So this is all my presentation. Thank you.